Okay, so starting our SOL review, if you look at the end of the year packet, we're going all the way back to Unit 1, where we were talking about properties of matter, elements, compounds, and mixtures. And if you go back to your original packet, you can look at this information that you should have there as well, or you can go back to the PowerPoint. And when we were talking, the first one is all matter can be classified as a element, a compound, or a mixture. So our first question is it uniform throughout? So if it's not, we're going to call that heterogeneous. If it is, we call that homogeneous. Homogeneous just means the same throughout. So if it's heterogeneous, it's going to be a mixture. If it's homogeneous, now we need to look at it a little bit more thoroughly. So can it be separated by physical means? If it can be separated by physical means, that means without chemical changes, then if that's true, we're going to say, well, then this is a homogeneous mixture. If it can't be separated by physical means, now we need to describe it as a pure substance. And this means either a compound, which is formed of more than two types of elements, or elements themselves. So if it can be decomposed through chemical processes, then it is a compound. And if it can't be decomposed through chemical processes, it is an element. So if you look down a little bit further, slide that up. If you look down a little bit further, now it's asking you to give some examples to define some terms. You can look these up, but we've just defined heterogeneous mixture as, you know, it looks different. For example, if I mix salt and pepper, you can see the pieces of the pepper, you can see the pieces of the salt. It looks different. It's a heterogeneous mixture, so maybe we have some big white pieces and some little dark pieces. So that would be a heterogeneous mixture. Homogeneous mixture, if we make a cup of tea with a tea bag, by the time we're done, the tea, it's a mixture of the tea particles, maybe a little sugar and water, but it looks like one consistent thing, so that would be a homogeneous mixture. Other examples of homogeneous mixtures are like the air. The air is a homogeneous mixture. You can't see the difference in it, but the pieces are different. All right, so colloids are special types of mixtures. And if you look back at our notes, I think that would have been pretty close after the bit about this flowchart. But colloids are things like mayonnaise or toothpaste. They look fairly uniform, but there's actually solid particles that are suspended in a liquid, but you can't see them suspended or separate that, or you can't see them very well. So these are a type of homogeneous mixture. All right. So continuing on, if you look, we've got solutions, you guys. So maybe what is a colloid? Toothpaste. We can put toothpaste on the toothbrush there. A solution, for example, if you go back, a solution is a type of homogeneous mixture. And that could be our tea again, it could be Kool-Aid, it could be our soda bottle with soda in it, and the gas bubbles are the solute. And lastly, we have our alloys. Alloys are also usually homogeneous mixtures. And you could think about things like brass. I guess we could do brass knuckles, although the brass knuckles or bronze. And so alloys are always two or more metals. All right, we're going to talk a lot more about colligative properties later, but colligative properties are things that are changed when we are a solution or a mixture. Let's see, some good example of colligative properties are things like boiling point depression or melting point elevation. Those are all colligative properties. If you look in our notes towards the end of Unit 1, you should see where they're talking about these different colligative properties. And so let's just start with vapor pressure or boiling point, things that change when you're in a solution. Change with the concentration of that solution. Okay. All right. We didn't do chromatography, distillation, or filtration. We did talk about it. Chromatography separates out liquids by their wicking property. I don't know if you guys know what wicking property is, but say we put this in, we crush up a leaf, and we crush it up, put some sort of a solvent in there, and then we dip a piece of filter paper in. What you're going to see is the different colors rise to different levels. The green pigment from the chlorophyll rises to a different level than some of the other pigments do. So you separate out by pulling liquids up through a filter paper. Distillation is when I mean, you guys might seen like stills or something where they take and they boil some liquid, and then they catch the condensation, and some things will condense out earlier than others. So we're going to boil, catch the vapors, and then because the different condensation points lets us pick out the different liquids at different times. And so that separates out the liquid. All right, lastly, filtration. This one's pretty straightforward. You might have done this if you ever played in a sandbox with like a sieve. I do this when I make cabbage juice indicator. You put some sort of filter paper. So we're going to pour the liquid plus any partially dissolved particles plus solid in through a filter, and the solid gets trapped and the liquid comes through. All right, so that is the first page of our end of year SOL review. If you missed that in class, you now have access to it.